This is Where We Live from Connecticut Public Radio. I'm Lucy Nalpathanchel. There was a media craze back in 2012 when scientists captured images of a live giant squid nearly 10 feet long in its natural habitat. In fact, Where We Live talked to one of the scientists on that research expedition, Dr. Edie Witter, about how the team used artificial bioluminescence to mimic a jellyfish, and that tactic successfully lured the giant squid into camera range. But did you know there's an even larger squid out there in the deep sea? The colossal squid. Coming up, we'll hear from a California nonprofit dedicated to filming and finding these rare sea creatures in their natural habitats with the goal of raising awareness about ocean conservation. We'll hear from one of the members of the environmental organization. That's coming up. First, you may be wondering, why are we talking about squid today? Recently, squid were in the news, all thanks to that wacky apple emoji. The squid emoji on your iPhone is anatomically incorrect. A squid biologist at UConn, Sarah McAnulty, explained to Gizmodo why the emoji was wrong. The image incorrectly had the squid's siphon on the squid's face. Her exact quote was, "It would be like having a butt on your forehead." Does this story ring a bell now? To set this record straight on squid, joining me now in studio for the hour is Sarah McAnulty, a squid biologist at the University of Connecticut. Sarah, welcome to our show.
Thanks for having me.
And for full disclosure, producer Lydia Brown may have an affinity for squid as much as you do.
That's amazing. The more people who love squid, the better.
Squid love here on Where We Live. So let's talk a little bit about that emoji before we talk more about the squid out there in our oceans. When you saw that squid emoji for the first time, this anatomically incorrect image of a squid, does that kind of show that we don't really know a lot about squid, the general public?
Yeah, I think that's a good way of putting that. So I think when you look at a squid, it's sort of hard to imagine where different parts of its body are. You go to the zoo, you look at a giraffe, and it's pretty much the head, shoulders, knees, and toes that you learned in preschool. But a squid, it's like arms, eyeballs, butt, and torso. It makes no real sense intuitively to a human or a vertebrate like us. So squid are super cool, but they're not as intuitively built as us. So it's understandable to get a little bit confused.
I mentioned that this squid emoji had the siphon on its face.
Yeah.
So explain where the siphon should be.
So basically, they just flipped it upside down. It was a pretty understandable mistake to make. So the siphon is typically right under the squid's face, and then they put it on top of its face. So it should just be on the other side of the body.
We were talking about it's not something that we're used to seeing when we go to the zoo. When we think about cephalopods, which squids are part of, can you talk about that classification?
Sure. So cephalopods include a bunch of different organisms, that some of which you're probably super familiar with and others that maybe you're not so much familiar with. So there's the squid, the kind that you get in calamari, and also a bunch of different kinds of squid. There's like over 350 different types of squid, and they're all super different from each other, which makes them a really fun category of animals to study. And then we also have octopuses and cuttlefish. Cuttlefish are more closely related to squid than octopus, and then also the nautilus. So nautiluses are these spiral-shaped shells that are often used in decoration, actually, but they're becoming super endangered because their shells are so gorgeous. So there's, the squid, octopus, cuttlefish, and nautilus.
When I mentioned cephalopod, maybe people don't really know that cephalopods have been around even longer than the dinosaur. Can you talk about that?
Yeah, no kidding. So cephalopods, there was a bunch of news stories that came out a little bit ago that was like, cephalopods, they're like aliens. But really, they are more earthlings than we are because they've been on Earth for 500 million years. This is longer than trees, longer than sharks. These guys are one of the original earthlings. So their evolution is super cool. So if you want to talk about that,
sure. Let's give us the timeline.
Sure. So about 500 million years ago, all ocean life was on the seafloor. And so everybody was walking around stuck to the bottom. And then the first cephalopod was shelled. It sort of had this cone-shaped shell. And they lifted off the bottom and became sort of like a little hovercraft. So they would be attacking things from above. And they were one of the first active swimming predators. And then from there, eventually, their shells became smaller. Well, first it became huge. They became like 3 meters long. You might see in museums these ginormous shells that look like the size of like a tiny house. They're like not huge. They can be big cones, they can be big spirals, they can be really intricate and have lots of little spikes coming off of them. They're really gorgeous. So eventually, it was basically an arms race between the fish and the cephalopods. And so every time fish got faster, cephalopods had to get better and faster at swimming. And eventually, they brought those shells inside their body and then lost them sometimes entirely.
And when we think about these ancestors of modern day squid, what were they called back then?
There's two different major groups. So there were the ammonites, and those were the spiral guys. And then there were belemnites, and those were more cone-shaped.
This is where we live. In studio with me is Sarah McAnulty. She's a squid biologist at the University of Connecticut. You can join our conversation, 860-275-7266, as we learn about squid, so many different squid in our oceans. And coming up later, we're going to talk about how fossils like belemnites were used back in early medieval age. But earlier, Sarah, I asked you about the different cephalopods, and you mentioned squid, cuttlefish, and octopus. Can you talk about some of the similarities they have and then the differences?
Sure, yeah. So squid and cuttlefish are the most similar. It's basically a tube with a face in the front. And so inside the tube is where they keep all of their organs, where they keep their gills, and what they use to swim. So these guys are using what's called jet propulsion to swim. So they basically take a deep breath of water into their bodies, and then they can seal it off right behind their eyes, and then they shoot that water out through a tiny hole called a siphon. And that siphon is what the apple emoji flipped on the wrong side of the squid. And so these guys can move super fast, and then they can control their movement with fins on either side. And so squid that you might eat and calamari have two little fins at the end, and cuttlefish have what looks almost like a bed skirt around the whole kind of rugby ball shaped body that they have. And so these guys are pretty similar. The main difference between a cuttlefish and a squid is that cuttlefish have what's called a cuttle bone. So if you have a bird, you might feed your bird a cuttle bone to get calcium into the bird's diet. It's basically a buoyancy device. It's an internal shell. And these guys can use that so that they don't have to put any effort in going up or down in the water. They can stay exactly where they are. And so then octopuses have a mantle, it's called, as well. So it's that like main body portion where the organs are. But then they have 8 arms. So these guys diverged away. So the octopuses and the squid and cuttlefish diverged a super long time ago in evolutionary history, which is why they look so different from each other.
In recent years, there's been a lot of attention on octopus, especially being intelligent animals. But this also carries over to squid?
Yeah, absolutely. So cuttlefish, I've worked with cuttlefish, octopus, and squid at this point. And octopus are very smart, but it's kind of like having a cat in that sometimes they just like don't want to cooperate with you. They may not want to be trained or whatever. But cuttlefish are kind of like a dog because you come in and they're super excited to see you. And they're just like very friendly and personable. And I just think they're the most fun animals to work with. So both of these animals are very intelligent. But what's kind of tough when we're thinking about animal intelligence is what really makes an animal smart, you know? So like I think a lot of times humans will look at an animal and think, okay, what do I think makes another person intelligent? And does this animal do what I would think a smart person would do? And when it comes to particularly invertebrates and animals that are left our track of evolution so long ago, you have to think what makes it smart for its environment. So all of these animals, the cephalopods, except for a couple exceptional weirdos, they can change color. So in their skin, they have little color-changing cells, and they also have like structure-changing cells. These cells that can stick up so they can look more like, for example, seaweed. So these guys, if they looked at us, they might be like, man, that animal's so dumb. It can't change color or shape. What an idiot. Meanwhile, we look at them and maybe they don't talk. Maybe they can't hear. So we don't think they're as smart. But they're great at problem solving. They're pretty decent at communication, considering that when they can change color to communicate with each other. So instead of language, verbally, they're using color and shape as language.
I was thinking back to that sci-fi video that went viral a couple years ago, where it was the octopus on the ocean floor, and the researcher that was filming it, you could actually see it was camouflage, and it changed quickly to get away from this researcher because of those cells that you mentioned.
Yeah, so those are called chromatophores, and basically it's like a little ball of pigment that's surrounded by a bunch of teeny tiny cell muscles. And so those muscles can pull that pigment apart. So instead of being like a teeny tiny little dot, it looks like a big like dinner plate of color. Sorry. And both these chromatophores can be in all different colors. You can have yellow ones and red ones and darker ones. And then under that cell layer, there's another type of color called iridophores. And these guys can actually change their color themselves. So they can go from blue to red depending on different chemicals in the squid's body. And these guys are really shiny. So if you ever see like a sparkly looking squid, at the University of Connecticut, we work on Hawaiian bobtail squid, and they look like little sparkly balls because of those iridophores in their skin. When the light hits them, it reflects that light back, and they look like little disco balls of squid.
So the disguise is important to get away from predators. Who are their main predators?
Each squid has a different group of predators, but basically squid are like swimming protein bars. They are the easiest thing to eat in the ocean because predators don't have to deal with bones. They don't have to deal with much of any structure inside. They can just gulp it down whole and they're good to go. So everybody wants to eat a squid. And they're really important in the ecosystem because they are super numerous and they reproduce very quickly. So they're a base food source for a lot of whales, for a lot of big fish, for tuna, for all sorts of different animals.
Oh, you talk about they reproduce quickly. What about longevity? How long do they live?
It can range, but most cephalopods live a year-ish or less. So that actually makes them really great at adapting quickly to different environments. So let's say you have, like, I don't know if you guys have heard this Greenland shark. It's this shark that lives for 400 years. It can take, I think, about 100 years to even reach sexual maturity before they can even have another Greenland shark. So these animals, if there's a quickly changing environment, they're up the creek without a paddle because they need 100 years to do one small change. But a squid that's reproducing maybe every 9 months, every year they can get a little bit better at what they're doing. And they have so many babies that you have each squid pair has the opportunity for a lot of different changes in one generation. So when you have 2,000 babies every generation, maybe some of them are just like you and won't do that well. Maybe others have an adaptation that's better for heat or better for pH changes, which the ocean is experiencing right now. So they're really maybe the future of the ocean and the past of the ocean.
Coming up, we're going to learn more about the research that you do in your lab at UConn with a particular type of squid. But I also had read that cephalopods are also considered ink fish. So talk about how squid use their ink.
Yeah, so squid use their ink in a bunch of really cool different ways. So one of the primary things that we think they use ink for, is just to get away from predators. So if they are being attacked, they might put out a big cloud of ink, sort of like a smoke bomb to confuse the predator. The ink also tastes kind of bad, so a fish would get ink in their mouth and just kind of be like, ugh, gross, and the squid can get away. They can also make what's called a pseudomorph, which is basically a blob of ink. So they take their ink, their pigment, and they mix it in with mucus, actually, to make that blob stick together. And so they can make that blob about the same size as their body. And so they shoot out the ink cloud that's the size of them and then jet out of there using that jet propulsion. And so the idea is that the predator thinks that ink blob is the squid, and then they attack the ink blob instead of the squid's body. And recently we're realizing that actually they use ink for more than just evasion. So there's this little tiny squid that lives in the Indo-Pacific. It's called the pygmy squid. It's like smaller than an inch. It's super tiny. And they use their ink for a really novel tactic. So they shoot out a little cloud of ink, and then they use that cloud as like a blind, effectively, to hide behind. And then they pounce through the ink to attack shrimp. So not only are they using it to get away from predators, they're also using it to attack their prey, which is just super cool.
I understand at one time you've been inked.
I have been inked. I've been inked a couple times, unfortunately. So if you work with cephalopods long enough, you're probably going to get inked. One time I was taking a blood sample from a squid, and it woke up like very quickly when I was trying to wake it up calmly, and it just inked me right in the face. And I deserved it. It's okay. It's all right.
Again, in studio with me is Sarah McAnulty, a squid biologist at the University of Connecticut. We touched on the siphon and how it's used to propel a squid, but can we talk more about how that works?
Sure.
Jet propulsion.
Sure, yeah. So basically, a squid is an open tube. And so the organs in the inside are basically open to the seawater. So you need that for breathing. So just like we breathe air into our lungs, they sort of breathe air into their whole body cavity. So it would be like breathing air into your entire like stomach area. And so they will take a bunch of water in, and then they have these like sheets that they can open and close. It's almost like a bulkhead. And so they can seal off that whole tube so that there's a lot of muscular force coming from all sides of the tube that they contract. And then the ability to shoot water out of a very small hole creates force that shoots them backwards.
That's pretty cool. And is it actually true that some cephalopods can fly?
They can, yeah. Yeah, this is so cool. So there's a squid called the Japanese flying squid, and these guys are stunning. So they aren't super big, but they use their fins to almost make like little airplane wings, and then they take their arms and web them together. So they make another like wing at the back, and they use that muscular force, and they can shoot like 50 to 100 meters out of the water. So they shoot out of the water and then just glide on the air to get away from predators.
That sounds pretty cool.
It's really beautiful, yeah.
This is Where We Live. I'm Lucy Nalpathanchel. My guest today, Sarah McAnulty, squid biologist at the University of Connecticut. After the break, we're going to continue talking with her, hear more about her research at UConn, and we're also going to touch base with a California nonprofit that's searching for elusive sea creatures like the colossal squid to raise awareness about ocean conservation. Do you have a question about squid or other cephalopods? Join us, 860-275-7266, or find us on Facebook and Twitter at Where We Live. This is Where We Live from Connecticut Public Radio. I'm Lucy Nalpathanchel. You've heard about the Kraken, mentioned in classic novels and in Scandinavian mythology. Today, there are actually research expeditions going on to find real, but very elusive sea creatures like the colossal squid. More on that in just a little bit. But today, we've been learning about squid from my guest, Sarah McAnulty, a squid biologist at the University of Connecticut. So I can tell you're really passionate about squid. When did this interest begin for you?
Well, when I was a little kid, I would go to the library a lot with my mom, and we would check out this one video that was a National Geographic Kids video called like Really Wild Animals, and one of them was all about the ocean. And about halfway through one of those videos that I would check out all the time, they would play like Twilight Zone music and then introduce the cuttlefish. And so cuttlefish, in addition to using color change for camouflage, also have this really cool tactic for confusing prey. And so it's called passing cloud. And basically it looks like a hypnotist's wheel, but moving across the body of a cephalopod. And so with the Twilight Zone music playing and this like weird pattern going across the animal, I was about 8 and I was just like, oh my God, that is the coolest thing I've ever seen. I need to know more about that. So I switched from being super into dinosaurs at the time to being super into cephalopods. And I've been really into them ever since.
So tell us specifically the type of squid that you are working with in your lab at UConn.
Yeah, so we work on Hawaiian bobtail squid, and they're really great animals to work with. They're about the size of a lime, so they're nice and easy to have in the lab. And what's really cool about them is that they have this partnership with bioluminescent bacteria. So these guys are nocturnal, and they use light from the bacteria that they keep in this little specialized organ called a light organ, appropriately. And they can use that light to camouflage from light coming down from above. So they can basically see, like, is it a super bright night out? Is it a cloudy night? And then control the amount of light that comes out from where the bacteria live to hide from predators below. Because if you're out swimming at night looking for food, a lot of times predators will look up to the sky to look for little silhouettes of animals that they can attack. And if you have a flashlight coming down from the bottom of you to hide, that keeps you hidden.
So when we think about the Hawaiian bobtail squid that you work with, how are they different from the other squid that we've talked about?
So they are different because they have a different sort of body shape. So instead of being like a little torpedo, they look like a little dumpling, basically. So they don't have any like hard structures on the inside of them except for a beak. They just, are just little dumplings. Yeah.
And so you're looking at the way bacteria is, how they handle bacteria because of the bioluminescence?
Right, exactly. So we use this bobtail squid because it's really nice to ask questions about how animals and bacteria talk to each other. So we all know that bacteria is super important for our health. We know that they live on our skin and our guts. They help us with digestion. They help us with our immune system. They're super essential for health. But if you look at an animal that intuitively looks more similar to us, like let's say a mouse, you have 100 to 1,000 species of bacteria that live inside that mouse's gut. And so if you have a squid, it seems super different, but they have just one species of bacteria inside this light organ. So that's basically like asking, okay, I want to understand communication between two organisms, but I only need to listen to two and not 1,001. So it's like listening to a quiet conversation in a small coffee shop as opposed to trying to understand everybody's conversation at like a loud club. So it really makes it nice to study.
How common is it for researchers to be using squid in their labs versus, say, mice?
So most research animals are like the mice, the flies, the things that you often hear about. But squid are really useful for a number of different things. So they are a key species historically for neuroscience research. So they have a ginormous axon that's in their back. And so people have used that to study how neurons function. And back in the 50s, this was like a really huge breakthrough for being able to understand because it's basically like having just something. The bigger something is to work with, the easier it is to work with. So it's essential for neuroscience and especially microbiome research now.
And how many colleagues do you have at UConn working with the squid that you work with?
There's one other graduate student, Andrea Surya, and also my PI, the guy who runs the lab. The professor is Spencer Nyholm.
This is Where We Live. Sarah McAnulty is with us, a squid biologist at the University of Connecticut. As we learn more about squid, do you have a question about squid or other cephalopods? The number 860-275-7266. We've been talking about your research. We understand that UConn has some research that will be coming public next week. Can you tell us about that related to the squid genome?
Yes, absolutely. So we are so excited. We've been working on the squid genome for like almost 10 years. And so having a genome is super exciting because that means that we can do things like CRISPR and other cool technologies that you really need a genome to have. So we sequenced the genome, and that will be coming out next week, and we are just so excited to share it with everybody.
And this is collaborating with Woods Hole?
This is collaborating with a bunch of different labs. So Woods Hole will be using the data because they have a whole big cephalopod group there. But the work was done by UConn and also University of Florida, University of Hawaii, and University of Vienna. So this was a lot of people who work on this squid species had to come together and do teamwork because putting a genome together is a really big job. And in cephalopods, the genomes are huge. So it's just a bear to deal with. So we have a lot of people working on it.
We were talking about your work in the lab, but what are the challenges in researching squid?
I guess the biggest challenge is keeping them alive. So you need to be pretty good at aquaculture, so taking care of animals that live in the ocean. So you need to have a big tank system to keep everybody healthy. You need to give them live food all the time. So we will go down to Groton and collect little shrimp that live in seaweed and bring them back to the lab to collect. To feed everybody, and that's probably the biggest challenge. Although I think it's worth it because they're super cool, they're adorable, and it's just totally worth all the hassle.
And remind me again how big they are, because you talked about the pygmy squid, which are the size of an ant, but the bobtail squid, the size of my finger?
Like a lime-ish, a little bit smaller than a lime. So they're big enough to work with, but not so big that they're going to break the bank on food.
This is Where We Live. We know oceans make up more than 90% of living space on Earth, and there's much scientists still don't know about the deep sea. There are research expeditions going on to learn more about our oceans and the animals that live in them. And so I wanted to welcome into our conversation now Matt Mulrennan, who's CEO of Colossal, which is an ocean exploration and conservation nonprofit in Venice, California. Matt, welcome to our show.
Hi, Lucy. Thanks for having me.
So tell us about your nonprofit, Colossal.
Yeah, so this is Colossal with a K, and so it's based off the Kraken as well as the colossal squid. And we have this one premier expedition that we're trying to organize about trying to find and film the colossal squid in its natural environment for the first time. So this will be an expedition down to the Southern Ocean to explore and try to find the colossal squid and show it to the world. This is the largest invertebrate on the planet, and we know very little about it. So we're trying to use that to draw attention to some of the big conservation challenges that the ocean faces at large, as well as what the colossal squid faces in its habitat down in the Southern Ocean.
Matt, I opened up the show talking about the film of the live squid that was captured in 2012 by researchers that include Dr. Edie Witter. How is this colossal squid different from these giant squid?
Yeah, so there's a few significant differences, and we've been talking to Dr. Edie Witter and others that found the giant squid a super exciting discovery. So people often kind of confuse the two, but they're quite different. So the colossal squid is the largest invertebrate on the planet by size, so by weight, right? So it grows to up to 1,600 pounds or more, and that's how we kind of judge animals' size. You know, the biggest land animal is the elephant, even though the giraffe could be taller, and the giant squid might be longer than the colossal squid, might be up to 50 to 60 feet long, whereas the colossal squid is about 40 to 45 feet long. So the giant squid may be longer, but it's definitely a larger animal in terms of girth, right, and in terms of mass. But the colossal squid is very different. It's going to be a much bigger challenge to find because it's probably an ambush hunter, right? So it's sitting there waiting for its prey to come to it. And the giant squid is a very active hunter and will go after prey. So how they found the giant squid on film, they used this really cool bioluminescent structure that Dr. Edie Witter developed, and they attracted the giant squid into it, as well as they used some baited lures as well. So we're thinking about a very similar approach to finding the colossal squid, except we're probably going to have to be very active about our search for the colossal squid and probably almost hit it on the head with something in order to film it and cover a pretty large area. So there's some significant differences, but we don't know a lot about the colossal squid's behavior. There's really only one or two papers in the world on this, so we've been reaching out and talking to the individuals that have published these papers to try and figure out how we're going to find the colossal squid. And it's truly an engineering challenge, which is really exciting.
Oh, you mentioned that there's not much that scientists know about the colossal squid. When was the first time it was discovered?
Yes, it was discovered in 1925, actually. We're coming up on the 100-year anniversary of its first discovery, and that's kind of our internal goal, is to try and find it in its natural environment before 2025. Now it's an external goal because I just told you. But it was discovered in 1925 in the stomach of a sperm whale, and they said, wow, this has really interesting tentacles. It has these hooked tentacles on it. This is different. So it's in a genus by itself. So they actually have found out a lot about the colossal squid because sperm whales love to eat them. And in the Southern Ocean, it might be up to 80% of the biomass that the sperm whale is eating, right? So they find these beaks in the stomach of sperm whales, and the colossal squid has the largest beak in the animal kingdom. So they found these huge beaks in the sperm whale stomachs when they were doing dissections, when we used to hunt sperm whales significantly. And so they learned a lot about the colossal squid from that. But we've really only found 8 whole specimens ever to dissect them. So we know very little about its basic biology, as well as we know almost nothing about its behavior, its distribution, its population size.
In the studio with me is Sarah McAnulty, a squid biologist at the University of Connecticut. Sarah, what do you think about Colossal with a K's mission to find Colossal with a C?
I think that's super cool. I mean, the colossal squid is like the stuff of legends. They're so cool. I would love to see the footage if they ever. I'm really rooting for you guys.
And Matt, I understand. So you've just secured a sizable grant to help with the technology to find the colossal squid.
Yeah. So we actually just did a prototyping of our technology. It's called the ACBAR. The autonomous camera for Kraken baiting and recording, and it's based off of Admiral Akbar, the famous character from Star Wars, famous for the line, "It's a trap." And we did that because this is a deep sea camera trap. So we just threw this in the deep sea off of San Diego and did some testing. We had a 360 camera on there, and we were able to film all these cool animals, siphonophores, chimera, even a squid, as well as a bunch of hagfish. And we were able to actually win this $20,000 prototyping prize through Conservation X Labs, and it was this ConX Tech Prize. So they gave us this $20,000 prize, and we're going to be using that to further the testing. We have limited resources, so we're using that to further the testing of the technologies that we want to use on the expedition. So we're very fortunate with that, and we're looking to do some exciting things this year, as well as we need to really lock down a vessel to get down there. So getting the research vessel is a big challenge. There's a limited window you can do research in the Southern Ocean near Antarctica between January to March. So we missed the window for this year, but we're looking to 2020 and beyond. But really doing that tech development has been really exciting. The Akbar could be a really cool tool just generally for deep sea research, because you can throw it off a small vessel. We put it off a 21-foot fishing vessel, and most research vessels are very large. They use big cranes to throw things in the water, and they can cost tens of thousands of dollars a day. So we're hoping this Akbar, we could actually anybody could throw it off their fishing boat, and explore the deep sea. And if we allow more people to actually get involved in deep sea research, we could find all sorts of cool things and trying to help protect them.
At the top of the segment, we mentioned Colossal, your organization, really hoping to raise awareness about ocean conservation. When we think about the colossal squid, the food that it exists on, is that an issue in terms of overfishing?
Yeah, absolutely. So it's got a really interesting story here. The colossal squid there's a really interesting paper called Alien versus Predator. That's quite literally the name of this scientific paper that is about this battle between the colossal squid and toothfish in the Southern Ocean. So the colossal squid will eat these toothfish. You may know that these toothfish as Chilean sea bass, right? So it's a famous story of overfishing. We labeled this species Chilean sea bass. It's not from Chile now, and it's not a sea bass at all. It's Antarctic toothfish or Patagonian toothfish. And the colossal squid will eat this and has an interesting balance of predator and prey throughout its life cycle. So at certain life stages, probably eating the toothfish. At other times in its life phase, the toothfish might be eating it. But we know that they have this relationship, and we've overfished down there significantly. There was a race to fish. We didn't realize that the Patagonian toothfish and the Antarctic toothfish, they don't even sexually mature until 25 years of age. So there's severe overfishing that happened there, and there's huge decisions right now happening that could help protect the colossal squid's habitat. Expanding marine protected areas off Antarctica, which we think we should. We never should have fished there in the first place. This is a very pristine habitat. And as well as the high seas treaties. So this is kind of like the Paris Climate Agreement for the oceans. This could help protect the high seas and close huge areas of ocean to fishing. And this would be really, really important for the ocean, because there's a ton of illegal fishing that happens in the colossal squid's habitat and overfishing that happens on the high seas. It's very lawless. So this Paris Climate Agreement for the ocean, this high seas treaty, is being discussed at the UN now, and over the next couple of years could start to be formalized. So we're going to be pushing for that, as well as we have a campaign to just push people to, if you eat seafood, eat local, eat small scale and eat local seafood. In the United States, we have very well-managed fisheries. We don't need to be getting fish from all the way off Antarctica just because it sounds a little bit exotic, and it's affecting a deep-sea habitat. Deep-sea fisheries are very vulnerable, and so we think we should switch to small, local fisheries instead. That's what we've been all about in Los Angeles, campaign to try and get restaurants and individuals to adopt local, sustainable seafood.
You're hearing Matt Mulrennan, CEO of Colossal, an ocean exploration and conservation nonprofit based in California, here on Where We Live. I wanted to turn back to our in-studio guest, Sarah McAnulty, a squid biologist at UConn. And we were hearing Matt talk about the consequences of overfishing. When we think about eating squid, how sustainable are they?
They're super sustainable as far as we know right now. So lately, in the last 10 years, there was a paper published about a year ago that was showing that their cephalopods are doing awesome in the ocean right now. They are increasing their population sizes, and we think part of that is because we've overfished fish so much that there are fewer predators around that are attacking them. So one other great thing about squid is that, like we said earlier, they reproduce much, much faster than fish. So if you fish a population, they can recover pretty quick. So if you're trying to decide on a sustainable seafood, particularly in Connecticut, eat more squid, because they're a decent thing for the ocean to eat.
Along those lines, when we think about our oceans warming, what will that mean for squid populations? What do scientists know?
It's tough to say. So we know that, like we said earlier, that squid are poised to pivot very quickly in the face of climate change. But we know that in the laboratory, they're very, very sensitive animals. So they're sensitive to pH. They're somewhat sensitive to temperature. It depends on the species. But there are some species that do well in a lot of different areas. And when you have a group of animals that has taken so many different approaches to its life history, so some that live deep, some that live in super warm water, some that live in super, the colossal squid in the Southern Ocean. Southern Ocean is cold. So we're hoping for those of us that are rooting for the squid that some squid will survive whatever we do to the ocean. And that may not be true for a lot of animals like whales, a lot of different fish. Many invertebrates are very delicate. So, we'll see what happens.
I want to thank Matt Mulrennan for joining us again, CEO of Colossal. That's Colossal with a K. We'll tweet out a link to your organization's website at Where We Live. Matt, thanks so much for your time.
Thank you so much for covering Squid. Thank you guys for having me.
This is Where We Live. I'm Lucy Nalpathanchel. We'd put out the number for listeners to call if they've got questions or comments about Squid. I want to go to Sarah in Meriden. Sarah, what's your question or comment?
Hi. My question is, how are squids' immune systems different from people's immune systems?
That's a great question. So
That
Sarah
is,
McAnulty in studio.
I'm literally a squid immunologist, so you're asking the right person. So humans have what's called an innate immune system, and that's like the immune system that's good to go when you're born. And then they have an adaptive immune system. And that adaptive immune system has things like antibodies. That's why vaccines work in people. And lots of different types of cells in you. But in a squid, we just have just the innate immune system. So you might think of it as being simpler, but we can learn a lot about us from them because the proteins on the surface of an immune cell in a squid are very similar to the ones that are in us. They're just they've basically got like a one-stop shop for cells. So just one type of cell called the hemocyte. And so that's the squid immune cell that we study at UConn.
So we've learned a little bit about the Hawaiian bobtail squid that you work with. We heard Matt talking about the search for the colossal squid. Any other squid that we should be paying attention to before we head to break?
Oh, geez. Where do you begin? Where to begin? There's one of my favorite squid is a squid that lives in Belize and in Japan. It's called Sepia-toothus. There's different species of Sepia-toothus, but they are gorgeous. I actually have a tattoo of one on my thigh. They are really brightly colored. They look a little bit like a cuttlefish, but they're not. And if you ever just need a calming moment in your day, just go on YouTube and type in Sepia-toothus. Good luck spelling it. And it's just a gorgeous animal.
And the ram's horn squid?
Oh, yeah, the ram's horn squid. Good point. Yeah. So the ram's horn squid is sort of like a relic of an earlier time. So ram's horn squid are so named because they have an internal shell that looks a lot like a ram's horn. So it's like this loose spiral. And so they are sort of off on their own in terms of like the tree of life. And they're just small, and we don't know a lot about them other than they have super cool shells.
Again, Sarah McAnulty is in studio with me here on Where We Live, a squid biologist at the University of Connecticut. Coming up after the break, we're going to learn more about the ancient ancestors of the modern-day squid and also the strange ways these fossils were used by people. You can join us, too. Find us on Facebook and Twitter at Where We Live. This is Where We Live from Connecticut Public Radio. I'm Lucy Nalpathanchel. We've been talking today with UConn biologist Sarah McAnulty about squid. But as cited in the book Squid Empire, and we also talked about this, the fossil record of cephalopods go way back. We're talking 500 million years ago. For more on the ancestors of modern squid, joining us by phone is Dr. Chris Duffin, scientist with the Natural History Museum in London. Chris, are you there?
Yes, I am. Good morning.
So thanks for joining us. Let's learn a little bit more about the belemnites.
Yes, belemnites are quite common as fossils. What they look like is a long cylinder with a pointed end. It looks a bit like a dart, I suppose, in some ways, and it's got a circular cross-section, and it's made up entirely of calcite, that's calcium carbonate, And they're very, very common as fossils. They range from the lower Jurassic rocks through to the late Cretaceous. They died out about the same time as the dinosaurs. And they lived in marine conditions. You find them in all sorts of rock types, but especially clays and sands and some limestones. And they are found all over the world. But in particular, they're quite common in the UK and Northern Europe, right the way through to the Alpine region.
When we think about these fossils, how were they used in medicine, Chris?
Well, yes, they've got a surprisingly long history of use in medicine. And they go by some very strange names as well, which either refer to their supposed origins or what they look like or what they do. We can go right the way back to the ancient Greeks with Theophrastus, who was one of the students of Plato on Lesbos, and he described what he called lingurian, which was lynx urine. And he said that the lynx would bury its urine in the sand in order to stop people coming along and digging it up because they found it to be precious. Now, what was it precious for? Well, we find out later on, when we come to the writings of Pliny the Elder in particular, that it was used for a variety of things, mostly ground up into a powder, but nevertheless useful, he said, to break up bladder stones. So what you would do is you'd scrape some of the powder off the surface of the belemnite, you'd mix it up in a suitable liquid and take it by mouth, and that would break up the stone in the bladder. He also said that it could cure jaundice if you swallow it in wine, or you'd only have to look at it in order to be cured. And then a little bit later, still in classical times, we see that there was a writer called Damigeron, and what he suggested was that it was very good for diarrhea, and another writer also suggested that it was useful for various lung diseases.
Chris, you mentioned a little bit about the shape. Understand some people back in the medieval time thought that they'd come from the sky. Can you explain why?
Yes, that's absolutely right. Well, you can sort of imagine a situation where out in the countryside there's an enormous thunderstorm with thunder and lightning, and then the farmer goes out in the sort of dawn to look at his crops the next morning, and lo and behold, in between the rows of crops you might find various fossils, including belemnites. And what's changed? They weren't there before. The thing that's changed is that there was a thunderstorm overnight, so that the suggestion arose that these belemnites and a few other fossil remains as well were actually the consequence of the thunderstorm. They might be fossil lightning bolts, or they were called thunderstones. And this was a very widespread folklore belief throughout northwest Europe.
And when did they fall out of favor as being seen as having a medicinal value, Chris?
Well, yes, they have a medicinal use right from classical times that I've been talking about up till about the 1750s. There is one writer, Sir John Hill, who explains that writing in 1751 they were still stocked in apothecary shops, but they weren't really used very much at the time. Probably their heyday of use was in the Renaissance times. After the invention of printing, some of the earliest printed texts suggest that belemnites were to be found in apothecary shops and used for a whole variety of diseases and in different ways. And that sort of legacy carried on right the way through Renaissance times, with many, many books referring to the uses of these belemnites as link stones in medicine.
We were talking about how humans use these fossils, but for themselves. But what about for animals too?
Yes, that's right. They did have veterinary applications. There are the two main ones. One person wrote that you would scrape the belemnite to form a powder and then blow the powder into horses' eyes. The idea would be to cure the horse of various eye diseases and distempers that it might be suffering from. Although I'm not sure, I would have imagined that would irritate the eye rather than cause it any benefit. So that was one application. And in the north of Scotland, particularly on the Isle of Skye, in the early 1700s, there was a suggestion that the belemnite could be used to cure the botfly. The botfly is a parasitic fly that lays its eggs on the skin of the foreleg, and irritates the skin. And when the horse licks it to ease the irritation, part of the life cycle goes into its stomach, and it causes growth of parasites in the stomach, which of course doesn't do the horse any good, and then the eggs are shed out of the back of the horse with the feces. And the idea was that by soaking belemnites in water overnight and then giving the horse the water to drink, that the horse would be protected against these bot flies and cured of the bot fly itself. They were called bot stones there.
Well, that's certainly interesting. Dr. Chris Duffin, scientist with the Natural History Museum in London. We want to thank you for telling us a little bit about how these fossils were used way back when. Thank you for joining us today.
Not at all. My pleasure.
I want to go back to our in-studio guest, Sarah McAnulty, a squid biologist at the University of Connecticut. Had you heard about how some of these fossils had been used in this way?
I actually just heard about this last week because this news article came out. And yeah, that's pretty bananas. I had no idea. Yeah.
Do you think you'd try that cocktail of belemnite powder into maybe milk and vodka?
Yikes. I'm not sure. We'd have to get a couple beers in me and then see what I say.
Speaking of the fact that, again, throughout the hour, we've been learning a little bit about the research that you're doing. You obviously are passionate about this. You helped found something called Skype a Scientist. I wanted to bring that up. Could you talk a little bit about that initiative?
You bet I can. So, yeah, I started a nonprofit called Skype a Scientist. It is a multinational group of scientists. We match up scientists in classrooms and groups of adults. Basically, anybody that wants to talk to a scientist in a kind of Q&A format, you can sign up on skypeascientist.com. We've served about 11,000 classrooms and groups of adults so far. The idea is that a lot of people have never met a scientist before, and we really want to change that. So we've gotten just an overwhelming response from the scientific community, because the scientific community also wants to talk to people as well. There's nothing a scientist loves more than to talk about science. So it's a totally free program. We are based at UConn. And yeah, if anybody wants to talk to science, we can match you up with any kind of scientist. So we've got everybody from astronomers to physicists to chemists and biologists, paleontologists, social scientists, anything you want.
Earlier, we talked about just a few of the many squid that are out there off the eastern seaboard. What are some squid that we can keep our eyes out for?
We pretty much have one main species of squid, and that's Doryteuthis pelei. So that's the squid that looks like a torpedo, and they're super abundant. There's a ton of them, and you can catch them in Stonington. You can catch in some parts of the year. All you need is a flashlight and a squid jig, which is like a little piece of metal with lots of hooks on it. And yeah, they're everywhere. So they're good eating. You can fry them up in calamari, or even my personal favorite way to eat squid is in squid ceviche. It's really nice, especially if you caught them that day. They live all from here, north of here, all the way down to the Gulf of Mexico.
We should mention before we let you go, Sarah, that you've been able to create a coloring book on squid.
Yes. So I just published about a month ago a squid coloring book. It's called the Incredible Cephalopod Coloring Book. You can get it on Amazon, and it's got a cephalopod for every letter of the alphabet. So I illustrated these pictures of cephalopods, and then there's a sentence or two about why each one is cool and noteworthy. So if you have a New Year's resolution of either relaxing, coloring more, getting more into your art, or learning a bit about squid, please check it out. I'm really proud of it, so I hope you like it.
We'll make sure that we tweet out a link to that as well.
Great.
And just before we let you go, when we think about the resources available to scientists to do their research, is there enough resources to do squid research?
I mean, I'm always going to say no, because I think there's so much more to learn about squid. We're realizing that there's a lot of squid really deep in the ocean, and it's hard to get there, and it's expensive to get there. So just like Colossal with K was talking about, there's so much more that we can learn from these animals. Both from learning about the animals to learn about us, from the microbiome to neuroscience to all sorts of different really cool applications. So, yeah, fund your squid researchers.
Well, we hope to have you back. Sarah McAnulty, again, squid biologist at the University of Connecticut. Thanks so much for coming in.
Thanks so much for having me on. This is really fun.
Today's show produced by senior producer Lydia Brown. Our technical producer is Kyone Wolf. Learn more about the show, WNPR.org/where we live. I'm Lucy Nalpathanchel. As always, thanks for listening.